Alright, so now this lesson we're going to look at the thing that a new method that I alluded to in an earlier lesson called the quadratic formula. And it's going to be a new way of finding the zeros of an equation in standard form. So just to recall here, going into today, the only thing we could do if we had a quadratic in standard form and we wanted to find the zeros of it, well, our first choice was to always try and factor it. If it factored it, then we put it into factored form, and from there it was relatively straightforward to find the zeros. We just set each factor equal to 0, and then solve for x. And it didn't take us too long. However, if it didn't factor, like a lot of expressions don't, then we were stuck when our only process was then try and put it into vertex form and then set y equal to 0 and solve for x. Now we had two ways of putting it into vertex form. We could either use partial factoring or we could complete the square. And then from that point there, we'd have to then again set y equal to 0 and solve for x. And we did an example like that towards the end of the last lesson. We had an equation which wound up, when we simplified it, getting 3x squared minus 12x plus 10 equals 0. It didn't factor, so we put it into vertex form, and we wound up with these two values for x-intercepts. I won't go through that entire equation again. You have your notes from last lesson. You can look through it there and follow through our steps. Or if you don't have any notes, you can always check through the video again. But we wound up with these two answers. But again, it was a bit of a long process. What I'm going to look at today is a different method of finding the zeros, and it's called the quadratic formula. So again, what's this used for? We're trying to find the zeros of an equation in standard form. So remember, standard form is ax squared plus bx plus c. Okay, and we're trying to find the zero, so that means the value of y is 0 in the equation. So if we have our coefficients a, b, and c from standard form, we can solve for x using this formula right here. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, a, b, and c come from the coefficients in standard form. Now, where this equation comes from, I won't go through the entire proof. It's a bit of a long process. It's in your textbook or available online if you want to take a look at it, or if you want me to go through it with you later, we can. Just let me know. But the whole idea is, pardon me, what they do is they take an equation, ax squared plus bx plus c, and they try to find the zeros of it by putting it into vertex form first and then setting y equal to 0. So I start by either completing the square using partial factoring, subbing that x value for the axis symmetry into the equation, finding the vertex, putting it into vertex form, and then setting y equal to 0 and solving for x. Now, as you can imagine, it's a bit of a long process. You can imagine if I was going to start completing the square here, I would factor the a value out of both of these terms. So I'd have x squared left. I'd have to divide the b by a. Okay, and then I have to try and complete the square with this. So I'd have x squared, b over a, if I split that in half, would be half b over a, or b over 2a. Okay, so I get x plus b over 2a, x plus b over 2a. And if I multiply these together to get a perfect square, I have b squared, b times b, and 2a times 2a for the denominators is 4a squared. So then I have to add b squared over 4a squared and subtract b squared over 4a squared, and then simplify from there. Once that was in vertex form, I'd wind up with y equals a, I'd be x plus b over 2a all squared, and I'd have minus b squared over 4a squared all times a plus c. And again, I'm not going to finish this up, I'm just going to stop here, but you set y equal to 0 and then solve for x. And what you wind up with is that quadratic formula that we just saw on the previous page. Now, one neat thing that comes from this as well is if you look at my axis symmetry here, I mean, I don't have the full vertex form, I didn't simplify this, but the axis symmetry here, my h value is going to be equal to negative b over 2a. Okay, and as you may remember, in vertex form, h is your axis symmetry, so I can always find my axis symmetry from standard form by just doing x equals negative b over 2a. So now that we've seen that whole process, we can actually find a nice quick way of finding the axis symmetry from standard form. Okay, so it's a little bit faster than some of the methods we'd seen previous to this as well. Okay, so a nice little side note that comes out of the quadratic formula is now we have a short way of the axis symmetry, but that's kind of beside the point. So again, now we have this formula to find the zeros. So let's try and apply that to the equation that we just looked at, the one that we did at the end of the last lesson. So if you have 3x squared minus 12x plus 10, again, the values of a, b, and c in the equation come from the coefficients from standard form. So I have my 3, my negative 12, and my 10. Those will be my A, B, and C values that I put in the equation for the quadratic formula. Okay, so now I'm going to try and use the quadratic formula to get my zeros, which will be hopefully much faster than what we did last lesson. Okay, so I'll take my quadratic formula, and I know what my A, B, and C are, so I'll just put all those in. And as ugly as the equation looks, it's actually not too bad to work with. You just got to be very careful with a few things. So remember, B is negative 12, and it's negative B in the equation. So it's negative 12 plus or minus the square root B squared. So that's negative 12 squared minus 4 times 3, which is A, and 10, which is C, all over 2A, which is 2 times 3. Okay, so let's just simplify this now. So I have negative 12 out in front here. That's going to give me positive 12. And off to the side here, I can do this in my calculator or do it step by step. So I'm going to have negative 12 squared minus 4 times 3 times 10. So that's going to give me negative 12 all squared, which is 144. And that gives me minus 4, 12, 120. So I get 24. So I get 12 plus or minus the square root of 24 all over 2 times 3, which is 6. Okay, so this is about as simplified as I can make it. Square root of 24 is not a nice number, so it means I have two different x-intercepts here. Okay, so I have x equals 12 plus the square root of 24, all divided by 6, or x equals 12 minus the square root of 24, all divided by 6. Okay, and let's compare those to the answers that we got when we did it the first time. Okay, so last lesson when we did it, we got these answers right here. Now, at first glance, you might think, oh, these look different. And if you look at the equation in radical form, 2 plus square root of 2/3, it does look a little different from what we have. But we actually do have the same thing, and we're going to check this by running both of these through our calculator. So in your calculator, take 12 plus square root of 24 and divide it by 6. Okay, and that should give you approximately 2.82. Okay, and 12 minus root 24 over 6 should give you approximately 1.18. So even though these two answers look different, you leave them in root form, they actually are the same. Now the reason we don't actually know how to simplify this form into this form just yet, that's something you would look at in 3U, but the important thing to look at here is that you get the exact same decimals for each one. So the answer we're getting here is the same answer we would have gotten doing it the previous way. And hopefully you find that once you start working with the quadratic formula, this will be a lot faster to work with. So normally I'm happy if you just leave your answers exact like you would have here, but if it asks to run to decimal places, you can take it further and write out the decimals there. Okay, so hopefully you find this a much faster way to find the zeros of a quadratic equation, okay, if it's in standard form. Okay, so some other things I want to mention about this before we go on. This part underneath the square root here, b squared minus 4ac, that has a special name. It's called the discriminant. And there's a note here, it says no solution if negative. So what that means is if you evaluate the b squared minus 4ac off to the side like I did over here, if you wind up with a negative number, that means you're going to have a negative number underneath the square root. If there's a negative number underneath the square root, that's not possible. You can't make that happen. Your calculator won't do it. It doesn't exist. So what that's telling you is that the equation has no solution. Okay, so we've seen that a few times solving our equation in vertex form, finding the zeros with the square root of a negative number means there's no zeros. Well, if you have negative under the square root here, it tells you there's no solution to the equation. Okay, with that in mind, let's try a few examples. So here, let's jump into the word problem here. So we have a height in meters of a ball of the ground can be modeled by the equation that you see there, where t is in seconds. We want to find the initial height of the ball and when the ball will hit the ground. And what I'm going to have you do first is just take a look at a graph of this one, just to have an idea of what's going on. So here's the graph of our equation, negative 5t squared plus 2t plus 4. The initial height of the ball, you can see on the graph here, it's going to be at 0, 4, so it means the initial height is going to be 4. Okay, and when the ball is going to hit the ground, well, we see the ball is going to hit the ground over here approximately. Yeah, can't get it to be 0 exactly, but you can see it's going to be around 1.12. Okay, so you can sort of see those answers from the graph, but again, how do we get that algebraically? So the initial height of the ball, what's going to help us here, if it's the initial height, that means no time has passed. Okay, it's a starting height, which means that t equals 0. Okay, so we can take the equation sub t equals 0 into it, so we're going to get h equals negative 5, 0 squared, plus 2 times 0, plus 4. Okay, which gives me 0 plus 0 plus 4, which is 4. So it tells you the initial height's 4 meters. Now, you may have been able to recognize that if it's the initial height, it's also going to be the y-intercept, or in this case, the h-intercept. Okay, so two different ways of getting the answer there. Now, for when the ball hits the ground, well, if it's on the ground, the height is equal to 0. So if we put in 0 into the equation, okay, looking to find the zeros of an equation standard form. So we have two ways of going about it. We can either factor it, if possible, or if it doesn't factor, we can either do what we did last lesson, which was put into vertex form, set y equals 0 and solve for x, or we could use the quadratic formula. Now, if you take a look at this one here, you'll see that factoring does not work. Okay, I'll need two numbers to multiply negative 20, add to 2, which doesn't actually happen. So what we're going to use is the quadratic formula here instead. Now, be careful here when I use the quadratic formula. The variable I'm solving for is no longer x, but it's actually t, so just be careful for that when you write out your equation. So it's going to be t equals instead of x equals. We can still get our a, b, and c values from the equation standard form. So a will be negative 5 in this case, b will be 2, and c will be 4. Okay, so I'd like you to try and figure this one out on your own first. Just run through the math and get your two answers from the quadratic formula, and we'll talk about what to do with them afterwards. But again, try and get the answers to work out, putting in a, b, and c into the equation, and simplifying as much as you possibly can. Okay, so take a minute here and check your answers. So when I subbed in all the numbers, I simplified underneath the square root, and I got 84 underneath the square root for my discriminant. So I have negative 2 plus or minus square root of 84 all over negative 10. Now, because this is a word problem, you check to make sure your answers make sense. So I found the decimal equivalent for each one. So I split up into my two zeros. I have t equals negative 2 plus root 84 over negative 10, and t equals negative 82 minus root 84 over negative 10. I ran both those through my calculator, and I got for my two answers negative 0.72 seconds and 1.12 seconds. So you have to think in the context of this problem here, are both of these valid? Remember, we're looking for when the ball hits the ground, and so this is going to be a time. Does it make sense for time to be negative? Looking at our graph here, we can see the ball hits the ground after 1.12 seconds, so that makes sense what we got. But this one over here does not make sense in the context of the problem. So going back to this, what we have to do is recognize that since time can't be negative, this answer right here is what we call inadmissible. I mean, mathematically, it's what the equation gave us, but it does not make any sense in the context of the problem because time has to be positive. So that gives us 1.12 seconds of the time it takes for the ball to hit the ground. Okay. So moving on, let's try another one here. So we have an equation, negative 17 equals negative 3x squared minus 24x. Again, to look at the graph here, what we're actually trying to solve here, if I give you the equation y equals negative 17, okay, which is somewhere down here, and the equation y equals negative 3x squared minus 24x, the right side of the equation, I'm trying to find the x values where these intersect. So if you look at the graph, I can sort of see it intersects twice there. But again, I need to be able to solve that equation algebraically. So let's go back to the equation here, and remember from last lesson, if we want to solve any quadratic equation, if it's not in vertex form, our goal is to get everything over on one side of the equal sign, so it's equal to 0 on the other, and then try and find the zeros of that equation, be it either from solving, quadratic formula, putting into vertex form, factoring, whatever works. So the first thing we want to do with any quadratic equation here is to put everything over on one side. So I'm going to add 17 to both sides of the equation. So I'm going to have 0 over here and negative 3x squared minus 24x plus 17. Okay, and now from here I can do either factoring, if it works. You can see if it does. If that doesn't factor, the best way to approach this would be to use quadratic formula. So I'm going to let you try this on your own, and then we're going to finish this up in part 2 of the lesson. So when we go to part 2, make sure you have this, if you've attempted to solve it first, so you can run through the answer together.